Where does your drinking water come from? If you live in a region of humid or mesic climate, where rainfall is regular and ample, it likely comes from a source close to home. But if you are among the rapidly growing number of people who live in arid and semi-arid environments around the world, it's likely that your water has traveled long distances to arrive at your sink. These transfers of water require significant infrastructure investments and energy to operate. Often they involve significant ecological consequences, both for the systems from which water is taken, as well as those where it is used. Although engineering and management data are available for individual water transfer systems, assessing the footprint and impacts of these systems over large areas can be challenging. As discussed in some of our other videos, isotope ratios of water vary naturally over space and time. If we can quantify this variation, it can provide a fingerprint, allowing researchers to use isotopic measurements to ask whether the tap water used in a particular city or town is likely of local origin or is transferred from outside the local hydrologic system. This is the approach that we took in a 2014 study focused on transported water use in the western United States. We measured isotope ratios of tap water from 612 towns within this region and asked the question, based on the isotopes, could it be local? We considered two possible local water sources. The first was local precipitation. Most groundwater aquifers and small stream systems collect precipitation that falls in the hydrologic basin within which the city or town lies. We used geographic information system layers produced by the U.S. Geological Survey to map the local hydrologic basin for each town. To characterize the isotopic composition of water that might end up in these local sources, we used a geostatistical model of precipitation isotope ratios, produced from a global dataset of rain and snow monitoring data. Within the GIS, we calculated the average and range of values characteristic of precipitation within each basin, a proxy for one type of local tap water. Because major rivers naturally move water between hydrologic basins, we also considered a second type of local water, derived from precipitation outside the basin, but transported naturally by rivers. Again, the starting point was our geostatistical precipitation isoscape, providing estimates of the isotope ratios of water falling at any point on the land surface. Using data on precipitation and evaporation amount and topography, we generated a model that represented the aggregation of precipitation and its isotope ratios downstream within watersheds. The result of this analysis was a data product showing the isotopic composition of river waters across the region. These look very similar to, but are subtly different than, the precipitation values. For both types of water, we found strong geographic gradients that could be useful for distinguishing between local and transferred water. Again, using the USGS hydrologic basin map, we used the GIS to extract average values and ranges for rivers within the local basin for each city or town. Now that we had characterized the isotope ratios of two types of local water, what remained was to use this information to evaluate the likelihood of local origin for tap water at each sampled town. For each tap water sample, we used Bayesian statistics to evaluate the conditional probability that the water was of local origin, given the isotopic composition of the sample and our information on the composition of local and non-local water sources. Because in many cases tap waters may be subject to evaporation during storage and transfer, our analysis also included a correction based on the Craig-Gordon model that estimated the original isotopic composition of the tap samples before any evaporation occurred. The results of this analysis show that at almost 30% of the sampled cities and towns, there is less than a 5% chance that the sampled tap water comes from either local source. With this information in hand, we can ask and answer some interesting questions about patterns of water transfer in the region. For example, by comparing our results with climatic, hydrologic, and socioeconomic data, we found that local population, rainfall amount, and income were important predictors of whether a city used imported water. With this information in hand, we developed a model predicting areas of the western United States where people are most likely to use non-local water. The model suggests that more than 40 million people within this region are likely using transferred water. So where does your water come from? Chances are that if you live in one of the yellow or orange regions on our map, it doesn't come from your backyard.